go to the exercise. These are the exercises that we did on Monday. Okay? And we can start with question number 1. They say that we have this reaction, aluminum chloride plus methyl ether, dimethyl ether, okay? And they are following the Lewis acid theory. Aluminum chloride is a Lewis acid, while the dimethyl ether is a Lewis base. Okay? Second question, if we have chloruric acid, hydrochloric acid, hydrochloric acid, and acetic acid, pK is -7, -11, and 4.7. Which is the stronger acid? Remember that the stronger acid will be the one that has the pK more negative or lower pK. That means this will be the more acid. Which will be the weaker acid? The weaker acid will be the one that has the pK higher. It's weaker acid. And which will have the stronger conjugate base? Again, weaker acids, strong or more strong conjugate base. A stronger conjugate base. Okay? Next one, if we have this reaction, HCl plus cyanide, don't do it at home. And we saw that the pK of hydrochloric acid is -7 and the pK of the HCl, cyanidic acid, is -2. For this reaction, which is the weaker acid? Again, the weaker acid is the one that has a higher pK, that means this is the weaker acid. Which is the weaker conjugate base? Well, the weaker conjugate base is the conjugate base of the stronger acid. That means that the chloride is the weaker conjugated base. And in which direction will go the reaction? Well, if the stronger acid is in this position, means that this acid will have more tendency to give the proton. That means that the reaction will go in this direction. Okay? Good. We go for the next question. Next question, we have these two compounds, okay, these two Newman projections. And this one. Okay, this is a staggered Newman projection, this is a eclipsed Newman projection. First of all, we have to ask, they ask which are the strains that we can see in the molecules. Basically, the strain here will be main torsional plus spheric strain, while here we will have only torsional strain. Okay, which of both will be more stable? Always a staggered conformation will be more stable than an eclipsed one. Okay? Next question, they say that we have this molecule. Okay? And they want that we draw all the energy in the diagram for all the conformants of this bond. Okay, the bond that is binding these two carbons. Okay, what I will do, how I resolve this problem, this exercise, is basically I will draw all the conformations possible, all the staggered and all the eclipsed conformation, and then I will draw the diagram. Okay, the first one, for example, I can draw this. That is, I put my eye here and I saw through the bond what I have is this. Then I rotate this in order to get the eclipsed conformation, number 2. Okay, the first atom will be always the same, and then I move the second in order to make the eclipsed conformation. I rotate again, number 3. Always the first carbon is not moving. I only rotate the second carbon, and what I get is 1. Okay? Staggered, eclipsed, staggered. I rotate again, and what I get now is again the staggered, again the eclipsed. Okay. I rotate again, 5, and this time what I get is the okay. I rotate again and I get the last eclipsed conformation. Hydrogen, metal. Okay? How I did it, remember. The only that I did is I keep the first atom intact. I didn't move, and then I rotate the second carbon. Okay, and I get the 6 conformations. Okay? When I have the 6 conformations, what I know? All the staggered conformations will be a minimum in the energy diagram. Remember energy, and here is the angle of the rotation. I start by the 1. Here is a minimum. 2, I have the 2, and here you can see that these 2, the conformation number 2 has eclipsed conformation that has to be a maximum, and the 2 big groups of the first carbon and the second carbon, in the case of the first carbon, is the iodide, and in the second carbon is the metal. Both are eclipsed one after the other. This means that this will be the higher eclipsed conformant, the higher energy eclipsed conformant. I put it here. This is 1, this is 2. Okay? Then we go for 3. 3, you can see here that we have the metal in the worst possible position, near to the iodide and near to the metal. Okay? This metal is close to the iodide and close to the metal. That means that could be the minimum which higher energy? Hold on. It will be conformer number 3. I go to the 4, and if I go to the 4, I check this conformer, we have the two metals eclipsed. That means it's bad. It's not as bad as here, because here we have an iron that is bigger than a metal, but it's not a very good situation. That means that this problem will be the second maximum energy possible. From here, I go up, and this will be number 4. Okay? Number 5, I have the metal and the iodide in anti. The two big groups, the most far away possible one of the other. That means that this means that this will be the minimum energy. The minimum started energy. This will be 5. And then 6, I have is eclipsed, but all the groups are facing a hydrogen. That means it's not so horrible, will be the eclipsed with the lower energy. And from 6, I come back to 1. Okay, this will be the energy diagram. Okay, we have to analyze each conformer, we have to check if it's staggered or eclipsed. Remember that all eclipses are maximums, all staggered are minimums. Okay, and then we compare all the eclipses together. For example, this has the two big groups, one after another, this will be the worst. Here we have the two metals, one after another, in eclipse position. This will be slightly more stable than this, but this will be the more stable because each big group is facing on the hydrogen. And the same for the stagger. We have to analyze one by one. Okay? Okay? Good. Then the next question is note the following. Compound 4 chloro, 5 euro, 2 dimethyl decay. If it's a decay means that the main chain are 10, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Decay. In the position 2 we have 2 metals. And in the position 4 we have a chloride, and in the position 5 we have an ion. And that's all. Okay, next one. Say that we have this one and ask us to put the name of this